The relationship between the sides of a parallelogram and its internal diagonals reveals a deep connection between geometry and balance. When we consider a parallelogram formed by two primary sides, these sides naturally define two internal paths, one diagonal representing their combined reach and the other representing the difference between them. The fundamental identity governing these diagonals acts as a mathematical mirror, reflecting the comparison of the side lengths through the interaction of the internal lines. This relationship shows that the way these diagonals cross is dictated entirely by how the lengths of the outer sides compare to one another. The most critical state in this relationship is the condition for orthogonality, or the point at which the diagonals become perfectly perpendicular. This specific alignment only occurs when the internal interaction between the diagonals reaches a state of neutral balance. For this to happen, the two sides that span the parallelogram must have exactly the same length. If the sides are unequal, the diagonals will always meet at a slanted oblique angle, but the moment the side lengths are perfectly matched, the diagonals are forced into a precise right-angled intersection. These principles allow for clear geometric classifications of shapes based on their internal properties. 1. Parallelogram. The standard state where the sides are of different lengths, resulting in diagonals that do not cross at right angles. 2. Rhombus. A specific version of the parallelogram where all sides are equal, which is visually and mathematically confirmed by its perpendicular diagonals. 3. Square. A refined case of the rhombus where the original sides were already perpendicular to each other. In this instance, the diagonals remain perpendicular but also become equal in length. From a practical and visual perspective, these concepts provide a reliable method for performing a magnitude check without needing direct measurement. By observing whether the sum and difference of two lines or vectors create a perpendicular crossing, one can instantly determine if those two lines are of equal length. Visual demonstrations and animations highlight this by showing a parallelogram stretching and shifting as one side changes. The moment the side lengths match, the shape clicks into a rhombus, often highlighted by the diagonals changing color to signal they have reached a 90-degree angle, providing immediate confirmation of the shape's transformation.